Okay, let's start out with mass percent. Coco? Okay, mass percent. And can anyone give me what the definition was for mass percent from yesterday? Okay, you're first.
Isn't it the percent of a certain material inside of a solution?
Yeah, but you got to be more specific. More specific than that. Coco, what do you have?
The percentage of, the amount of percent of mass of the solute in the solution.
Good. Grams of solute over grams of solution. You should be writing this down.
We can't see anything.
Oh, sorry. Let's take care of that problem. There we go.
Is it for a journal?
Yeah, this would go in your journal. It would make a great journal. Now, what is solute, what is solvent, and what is solution? So let's try and figure those out. Pamela, what's the solute? Shh. We're looking at this right now, and I'm asking you to look at your notes for yesterday and see if you can come up with what we mean by solute. Okay?
Like the definition?
Yeah.
Okay. I don't have it.
I haven't. Let's go on to Lily. No, Lily's not here. Sabina, how about it?
Which word?
We're looking for solute.
Got it. Dissolves, right?
Wait, was that not definition?
Yeah. Go ahead. No, not that way. Raphael? No. Elena?
The thing that dissolves inside of the solution.
Thing that dissolves in the solution.
I just said that.
Yeah, well, I wanted it different. Okay, I wanted it to be said in nice little, yes, human-type terms. Okay, so this is the stuff that's dissolved in this. So if I pour salt into water, who's the solute? Salt. Got it. Okay, so that's what we're trying to get to with this little exercise here. Now, when we multiply this by 100, that gives us the percent, right? So this is our mass percent. Take notes or do sentences. What do you want? Now, the other little thing that you're going to need is 1 mil is equal to 1 gram if we're talking about water and water only. Now, that's important because of what I'm going to give you right now for given and find. So, we've got a given here of 5.5 grams of sodium chloride. That's our salt. And we're going to have 20 decimal mils. I put the decimal. Why did I put the decimal in there, Arthur? Why did I put the decimal in there? So we have 2 sig figs, yeah. Okay? And then what we're supposed to find now is mass percent. Okay? So, let's go to Stephanie. Now, here, let's go to Kevin. Okay, Kevin? How are we going to get this guy to go? We don't have grams here, so what could we do to get this into grams? How do we do that? Oh, sorry. It isn't water. This is water. Okay, how do we get this into grams? Okay, how many mils? Where are you getting 2 from? Yes, indeed. 1 mil. And what's on top? Yes. How many? Yeah, it's 1 for 1. All right, so we can convert that very easily to 20 grams. Now, what do we do next? Yes. Yeah, sure. Actually, on this one, you can just rewrite it. You can just rewrite the mils because they are 1 for 1. Anytime you have a 1 for like this and it's just a one-step grid, you don't need to do that. Okay, you can just go ahead. Now, what should we do next, Kevin? What do we put over what? What's on the top?
20 grams.
Yes, there you go. 5.5 mils, or not mils, grams, over. No, it's not 20. 20 is the solvent. How much is the solution? Shh, Kevin. Yes, indeed. So what is it? Yeah, you got it. 25.5, and that's the grams of solution. This is solute, and this is solution. All right, so what else do we need here, Kevin? Times what? Yeah, you got it. Good. Okay, and so when we run our numbers here, we're going to wind up with 5.5 divided by 25.5. And when we multiply this guy by 100, it moves the decimal over 2. And when that goes over 2, we're also going to have to round this guy off, which makes it 22. And that's 22 is our mass percent, so that is a percent.
Right, what problem is this?
Okay? Yeah, this is not a problem. This is just something that I'm giving you as an example. Okay? And let's go down and do another one. I'm going to do this a little bit faster because I'd like to get both of these on one video. Molarity. Now, from yesterday, you might remember that we did moles of solute. Now, that's different than grams of solute, yes? All right, so moles of solute over, instead of grams of solution, it's going to be liters of solution. So it's a different way to measure things. All right, there's both measures of concentration, yes? Oh, sure, you want that up a little higher? Okay, I was trying to be able to show both at one time. So now this is equal to big M. Now that's something for your help sheet for the next quiz. And this is something that you want to keep in mind for all your problems for tonight, because you're going to be working with molarity tonight. Now I'd like to do the same givens. See, our givens will be 5.5 grams of sodium chloride and 20 mils of water, which is our solvent. And over here on the find, we're looking for big M. Now when you see that, the first thing you should do is right away, in parenthesis or circled or something, I want you to look at this as moles over liters. Keep that picture in your mind. Okay? Now when we go to solve this, can we put our grams into moles? Is there a way to do that? Okay, and how do we do that? 5.5 grams sodium chloride over, come on, this is the given, over 1. Now, what's next? This guy weighs 58 grams. So what goes on the bottom of this next fraction? 58 grams. Good. 58 grams is, on the top, 1 mole. Great. Now we're ready to get this guy into moles, and we got 58 divided by, 5.5, sorry. 5.5 divided by 58, and that's going to give us equal to 0.094, 2 sig figs, so this would be 5, because we round this 8 up to make that 5. And what is this? What's the unit of measure? Moles, yes. So that's the moles of our sodium chloride. Ah, look, see, that's the top of molarity, and that's what we're supposed to find. We're partway there, aren't we?
Yeah.
Okay, now, how about this mils? Do I have to do anything with it? Yeah, Jeremy? Yeah, we got to make this guy into liters. So 20 mils of water, and that's over 1. How many milliliters in a liter?
1,000.
1,000. 1,000 mils, top or bottom?
Bottom.
Bottom, so we can cross out. Right on. And this is our liters. What? Yeah, oh, no, that's okay. All right, so now we're good to go, right? Move our decimal 3 to the left, 0.020, And we got liters with 2 sig figs, which is what we want. Now, are we ready to go? Can we plug and play? Moles. 0.095 moles. Yes. And that's over 0.020 liters. And now we're all set to be able to calculate our molarity. So now we need 0.095 divided by 0.020. And there we go, 4.75. And that is our big M. That's it.